Okay, students, today we are going to learn about, this is lesson number 7.0, okay? Last time it was 7.5. Remember the handout that I gave, it was 7.1. So this is 7.0 and the learning target is proving compound identities. And what is compound identities is one of them is this one, cosine A minus B, and I put the color code. Do you see green color, the red color? So there are two angles, A and B. The green is the bigger one I took. B is, doesn't matter, but just A is the bigger one, B is the smaller one, and you can see it is repeated cosine A, B, A, B. The good thing is, watch this. It's the distributive property says everyone thinks that is it like this? If I have cosine of A minus B, and the question is, watch this. No, I want you to get it. See, usually students think, you know what, if I have cosine A minus B, you can just distribute, distribution property. Like how we write A, B minus C is AB minus AC. Do you remember that?
Yeah.
So everybody thinks that, oh, this is cosine A minus cosine B. And it can be proved that this is not correct. And I can take a simple example. Let's write cosine of, let's see, 60 minus 45 degrees. Or let's say 60 minus 30 degrees. I just want to make sure that that doesn't work, okay? So the question is this really true? Can I write this cosine 60 minus cosine of 30? We want to make sure is it really true or not. But what is cosine 60 minus, let's take instead of, I don't want you to get, because I want to get different. Let's take it at,
Is the 60 and 30 in degrees?
in degrees, yeah. This one is taken in degrees just to get an idea, or I will take, let's take it 30 degrees. Just to make it easy, okay? Because you can write pi by 3 minus pi by 6 also like that.
Yeah.
This makes it a little easy. But we do know the left side, if I subtract, it becomes cosine 30, right?
And that would just be 30.
Now this is cosine 60 minus cosine 30. But cosine 30 is, how much is cosine 30 from the chart if you remember?
3 squared.
This is plus, I think I made a mistake, this should be. What is that? Root 3 over 2, right? And cosine 60 is? Quick. The chart. Plus, and cosine 30 is? Do you think they are same?
No.
This one is square root 3 by 2, right? This is square root of 3 by 2. There's more additional stuff here, so it can't be. So that means we can't, this is wrong. So the formula doesn't work like that. So this formula doesn't work. If that formula doesn't work, then what works? That's why we have something like that. Can you see that? So we want to know. So what I'm going to do is, let me take those angle A and B using the circle. Can you draw this quickly fast on your paper? Yeah. And then x-axis, y-axis. Okay. So I'm going to use the green color as the angle. So angle A. So I take the angle A in such a way the initial side is along the x-axis. Okay, that one. And maybe this this is the angle, a little more than 90. Okay. So this angle is taken as, this angle is A. So let me write this is A. Okay. Got it? Can you tell me if that angle is A, what will be the coordinate of this point? What do you think is the coordinate of this?
Negative, positive.
Negative positive is correct, but in terms of cosine and sine.
Okay, so cosine probably 120.
No, the angle. We are not using the degrees. The actual measure, the letter used is A. The angle is A. So the theta that we talk about, that's A.
Yes.
So how do we write the x coordinate and the y coordinate?
Cosine.
Cosine of the angle, and the angle is
Negative.
A, right?
Yeah.
Now the angle is A, we don't write theta over 120.
Yeah, but it would be negative cos, right?
That is if it was, let's say, 120, and then it will be negative, as you are saying, is minus, but we are not writing in that. Okay. Good question, man. So that's cosine A, and what should be the other one?
Sin A.
Sine of. My question is, did you understand this so far?
Yeah.
If you got this, then the rest is easy. Okay. Now we will take the red angle. This time the red angle, I'm going to take this one. This, let's take this as x. So again, initial side I'll use this one along the x-axis. This angle is taken as 90. Do you see the color coding? Yes or no?
Yeah.
So if that angle is B, can we quickly write what are the coordinates of this? So this point, let's call this as, I'm going to call this point as P. Let's call this point P. This point, let's call it Q. And now, what are the coordinates of this?
Cos B.
Cosine of, yeah, very good, cosine B, cos B. Yeah, actually that's how you read it, cosine B. I always say cosine. Actually it's cos, shortcut. So cosine B and what else? Sine.
But what I mean is,
Mm.
because it's on this side, because it's in the third quadrant, would it cos be negative? There would be a negative in front of the cos.
What you're saying is, I know you're saying, but when we define the angle cosine is always the angle from from here all the way here. That's the one.
Yeah.
Okay? But we are not figuring out the reference angle kind of thing where you write it 180 minus. Remember if it was? Okay, now next is, do you see the black? Do you see the red and the green marker here? I use one for the red. Do you see there are two colors, right? So that part, let's call this is PQ, and let's call this as R. Can you write this R? And what are the now we are using the unit circle. Actually, everything is 1, 1, 1, 1. Can you tell me what are the coordinates of R here?
0, 0.
Is it 0, 0 or 1, 0 or 0, 1?
0, 1. No, 1, 0.
1. Can you write this? We are almost there now. What I do next part is I need another scale now. Okay. Okay. I'm going to use this. No, that doesn't happen. Watch this, okay? This angle now, I'm going to watch this, huh? This angle, do you see this angle? What do you think is this angle now? How much is this angle? My question is, how much is this angle now?
A minus B.
Yes! Let's finish this, forget the class, let's go home. Wow, you made my day today. You always do that, right? So it is A minus B, and that's many students don't get this, okay, because this is A, that is B, this is A minus B, right? Agree?
Yeah.
Vishal, do you agree, right? What I do next is, remember now, it's better to write at the bottom. It is PO, this let's call it origin. POQ is A minus B. Okay? So what we do next is this angle I'm going to rotate, this angle rotate around. So you rotate around the point, around origin, clockwise by, and so you're rotating A minus B. So this angle you're going to rotate, but you're rotating in such a way that you want to bring this OQ, I want to align with this x-axis. So rotate clockwise by an angle measures measures QOR. QOR. This is a little confusing now. Huh? Watch this. This is the angle POQ, right? Agree? Yes or no?
Yeah.
Now, I want you to rotate this by how much? Whatever this angle is. Can you see this?
Yeah.
Whatever this is. This could be 70, 60, I don't know. Just whatever. The name of the angle is QOR. So I go rotate that. In the other way, you just have to move this part. Do you see what's happening? Good. So that point is right here. Can you see that?
Yeah.
So what I'm going to do is P, and this I put P prime, because this dot, it rotates, when you rotate in the clockwise direction by that angle, this part is this part. That part is P prime. You have a new one. Now can you tell me what are the coordinates there? Quickly. So this part is, so now I have to use a different color for this, because there's too much stuff. See, so I'm using I'm going to use an orange color. So this green color now moves right here, correct?
Yeah.
Okay. And I'm going to put another orange color because this red one goes there, so you get an orange angle. Yes or no?
Yeah.
See, 3 colors. That orange angle now, this angle is how much? There's not too much of stuff here, so I'll try to write. How much is this also is? A. It is A minus B. Because it's the same, this angle that you had went there, right? So that also. So what are the coordinates? Now the angle is A minus B. So can we use the same definition of the x coordinate is always the cosine?
Yeah.
So this becomes cosine of what? What's the angle?
A minus
A minus B. And then sine of, what is that?
A minus B.
Again A minus B. Did you get something here?
Yes.
Makes sense, right? So A minus. Now what we do next is join. We try to draw 2 chords. One we will use the orange. So join this. Okay? So join P prime R, and also let's join the green one. Let me use this part. So PQ, join PQ. Okay, I'm sorry, I'll just do it fast now. Now I'll go. Now we have, see, from the graph, you can clearly see from the graph, from the figure, you see PQ, this PQ, or you can say P prime QR. So I'll write P prime R. This chord is the same as PQ. Do you agree with that?
Mm-hmm.
Do you agree with this? Because they are the same chord, right? See, this orange angle you got because of this, right? So if you join this, it is the same thing as here. So there are 2 chords we are talking about. First chord is, I'm going to use this one. So how do we find this distance? This is like a x1, y1. Do you remember the distance formula?
Yeah.
X2, y2. It's like x, so I'm gonna write that here. So it's the, so P prime is, this is how I have to start. X1 is cosine. Now I'm gonna go a little fast, okay? So cosine of minus B. Okay. I'll make this, continue this video, okay? And you can have a look on the YouTube. Is that okay?
Yeah.
So I'm gonna continue this because it will take another 5 minutes. Okay, so you see this cosine x1 minus x2. So the formula is, so distance formula D is x1 minus x2 the whole square plus y1 minus y2 the whole square. In place of this and the square root, this make sure you check afterward, okay? So this we can, if you square both sides, it's same as writing this square is x1 minus x2 the whole square plus y1. So instead of writing this, we can skip one step and write, okay, this is p prime r the whole square and pq the whole square. So let's apply the distance formula to this one. So this is x1. So cosine of a minus b minus x2, which is 1, okay, the whole square, plus then y1 minus y2, which is sine minus y2 is 0. Okay. So this is for this chord, and now I have to use for the green chord, it is this. So once we are done with this, then we have x1, y1, then x2, y2. So you apply the same formula. So I'm not putting square root because I'm applying the second one. So this is cos x1 cosine A minus cosine B, sine A minus sine B. That's what I'm going to write here. Cosine A minus cosine B plus now we use another formula is, what is A minus B? The whole square is A squared minus 2AB plus B squared. So this is of the form, so this part is like A, and this is kind of a B. So you square the first, that is cosine square of A minus B, and minus 2 times the same cosine. I'll make a little room on the left side here because you will have a lot of stuff on the right. So this is cosine of square A minus B so cosine square A minus B minus 2AB 2 times again cosine A minus B and times 1 because B is 1 and then plus 1 squared. So this takes care of the first one. There is a minus 0, so this goes away. So what stays is only sine. So this straight away we can write sine square of A minus B. The right side we will use this again here. This is A, this is B. So do the same thing, A square square cosine square minus 2 times cosine of A times cosine of B plus square cosine okay. And then next is I'm gonna use formula for this one. This is A and that's B. So again sine square. So I'll just write below that plus sine square A. Then minus 2 sine A sine B. So that's AB. A is cos AB is sine A cosine sine B plus sine of square B. Okay, so we're almost there. So what do we do next is this 2 parts and this 2 by Pythagorean identity will be 1. Same thing, this one will combine with this, give you 1. So cosine square plus they have the same angle, this also is the same. So this will be total will be 1 by Pythagorean identity. So it will be 1. And then there's also, so let me write this step, cosine of A minus B is 1 here plus 1. This will be 1. This stays the same, you can't do nothing about it. This stays the same. And this adds up to 1 again, so that is plus 1. This is plus 1. Okay? And then let's check. This 1 and 1, this together will be, this one will be 2 minus 2 cosine of A minus B. Then this one and this, it will be also 2. This stays the same. Now, you can subtract 2 both sides. So if you subtract 2 both sides, yes, I'm just finishing. This will be minus 2 cosine B equals, I missed a minus 2 here, so at the same time as you do this, we can use the distributive property. This crosses out. I'm almost done, okay? This crosses out, and this minus 2 and this minus 2, we can use undo distributive property and write it with plus. And then you can divide one more time by minus 2 both sides, and you get, eventually we get the final answer, compound identity, that is cosine A minus B, cosine of A, cosine of B, plus sine of A, and sine of B, and there you go. This is the most important formula, because if I want to write cosine of pi by 12, we can always write this as cosine of 4 pi minus 3 pi by 12, and break it down as cosine of 4 pi divided by this is will be pi by 3, and this will be pi by 4, and then you can use cosine of pi by 3 times cosine of pi by 4 plus sine of pi by 3, and you can easily know those answers from the unit circle, and that's how we can solve a lot of problems. So in the next class, you will see we will be doing a lot of problems as y. So this one was cosine A minus y, cosine of A plus B is cos A cos B minus sine A sine B. We'll also see y sine of A plus B is sine A cosine B plus cosine A sine B. And if there is a minus, then it becomes minus. So this is what we are going to do when we come back from vacation. All the best, take care, and hope this video helps to understand why the heck we have this compound identity. And the reason is, you saw the whole proof, what is the reason? And the next is how to apply it. Thanks for watching, hope it helps.